Today, I'm going to talk about problem 9 from the sample midterm. This is about the method of undetermined coefficients, and in particular, finding the form of the particular solution to a linear, non-homogeneous ODE with constant coefficients. But we're not going to try to find those constants A, B, C, however many there are, because that takes a lot of work. But this part doesn't really take much work, just understanding. All right. So all of these, remember, have constant coefficients on the left-hand side, and on the right-hand side, they're all the kind of functions that you get as solutions to a linear homogeneous ODE with constant coefficients. You get sines and cosines, you get exponentials, you get polynomials, and you get products and sums of all those things. But if the right-hand side is like has a log in it or an arctangent, you're not going to use this method, right? Okay, let's start here. For this first one, by the way, I'm going to start with the rule 1. Actually, we're using YP. So YP is going to be A cos 2t plus B sine 2t. And that is the most general solution that you have to linear homogeneous ODE with constant coefficients. It has 3 sine 2t as a solution, right? Okay. So, but we have to ask the question, do we have to multiply this whole thing by a t or a t squared or a t cubed? That's rule 2. Okay. So let's think about this. This guy has the roots of the characteristic equation are going to be r is 2 and 2. And this, we call it r prime is plus or minus 2i, right? The roots of plus or minus 2i are what give you sine 2t and cos 2t. That's what they have here. But there's no 2i over here, so this is cool. Rule 2 does not apply. Okay, for this one, we have the right-hand side is the same, so rule 1 is exactly the same. Yp is going to be A cos 2t plus B sine of 2t. And that also has r prime is plus or minus 2i. Those are the roots that give you sine t and cos t, sine 2t and cos 2t. But over here, you notice the roots of the left-hand side are also plus or minus 2i. Right? So in other words, if I tried to solve this non-homogeneous ODE by plugging in this, I would get 0 on the left-hand side. So what is the remedy of that problem? I just multiply this whole thing by t. Okay? And I would be probably spending 20 to 25 minutes to actually find A and B, plugging it into this left-hand side. Got to make sure I do all the whole man. It's going to be a lot of work. So it's nice that we don't have to solve for those coefficients A and B. All right. Over here, what do we get? In order to get an e to the 2t, I would get a root of r prime is 2. But to get t e to the 2t, I need another one, right? So that means that rule 1 says that yp is something, maybe, times a e to the 2t plus b t e to the 2t. Right? If I get a solution that looks like 5t e to the 2t to a linear homogeneous ODE with constant coefficients, the roots would be r prime, which is 2 and 2. And if that was a solution, I'd have to have, in other words, a equals 0, b equals 5. If that's a solution, I also get a solution like 3e to the 2t plus 7t e to the 2t, right? So that is the general solution of a linear homogeneous ODE with constant coefficients that includes 5t e to the 2t, right? That's rule 1. Now the question is, do I have to modify that? And here I have to modify it with spades, because look at this. The roots here are r is 2 and 2, right? So that means I have to multiply this by t squared, right? Because if I plug in e to the 2t, the left-hand side, I get 0. If I plug in t e to the 2t on the left-hand side, I get 0. But if I plug in t squared e to the 2t, I don't get 0. Okay? So that's why the smallest power of t, if I need to multiply this rule 1 guess by, in order that none of the solutions in here are in YH. Okay? All right. So what about this one here? Oh, wow, we have there we had sine 2t, here we have cos 2t. It doesn't really matter for rule 1. Rule 1 still has a cos 2t plus b sine 2t. And that's what you get from the roots from the right-hand side. The r prime is plus or minus 2i, right? So if it's 3 sine 2t or 4 cos 2t or 7 sine 2t plus 5 cos 2t, I still get the same rule 1 guess. Now, do I have to modify that with the rule 2? Well, here the rules are the roots on the left-hand side are 1 and 2, no plus or minus 2i, so I don't have to modify it. Okay. What do we have here? Okay. Yp is going to be, what do we get? A e to the 2t. That's rule 1, because if the solution on the right-hand side of e to the 2t, then the most general solution to a linear homogeneous ODE is that one. Now, that's what's right there. That's r prime is 2. What about the left? I have r is plus or minus 2, right? Because I'm solving r squared minus 4 is 0, or r squared is 4, r is plus or minus 2. Oh, there is one. There is a plus 2 there, so I have to multiply this by t. Right? Because there, if I plug that into the left-hand side, I get 0. So I can't set 0 to be e to the 2t. If I plug that into the left-hand side, I get a times some junk, and I can solve for a. All right, so finally here, this last one, if the right-hand side is t, that means I have to do at plus b, right? That comes from the roots of r prime are 0 and 0. Sometimes these roots of 0 are the trickiest ones to think about, because I get e to the 0t, which is 1, and t e to the 0t, which is t. Okay, if the roots are 0 and 0. In other words, the annihilator of the right-hand side is just d squared. Okay. Now what I have on the left-hand side, the roots again are r is plus or minus 2i. Nope, there's no zeros there. So this is cool, does not need to be modified.